In this video, I want to show you the foundation that I'm building for a 42 by 80 foot fabric structure. I got it from the Calhoun company. I'm pretty impressed with my dealings with them so far. Everything's been great. This plans package came with it, and this is the footprint required for this building. I'll be talking more about this sort of thing in future videos, but my situation is kind of unusual here. Manitoulin has a lot of exposed limestone bedrock, and that's what you see here. And as bedrock goes, it's pretty flat, but of course it's not perfectly flat and perfectly level, and that's the reason for the wall. What you see here now are the forms I'm building, and I'm doing that in kind of an unusual way. The challenge here is to have the form follow the rock in a way that can contain concrete, and that's not that easy to do if all you're using is plywood or some steel form panels or anything like that. So that's why I'm using a kind of fabric material designed for concrete forming. So let's go over there and we'll take a look. I'll show you all the things I've done so far and some of the things I have yet to do before the concrete trucks come. This part of the form here is pretty well complete at this stage. And as with any concrete form, you need to start with something you can rely on in terms of positioning, and that's where this 5/8 steel rebar comes in. Holes are drilled into the rock 4 or 5 inches deep. It just so happens that this rebar pounds very nicely into 5/8 inch diameter holes. So that's what I started with, and that contains the wood and will contain the concrete. And then when it comes time to strip the forms, we'll just be using a zip disc on a grinder, cut those off at ground level and start splitting off the wood and salvaging that wood too. I'm going to be making walls for this structure, so all of this form wood is going to come in handy. And that's one reason why I decided to use this fabric method from a British Columbia, Canada company called Fastfoot. This is a very strong tarp material, and it's used most commonly for creating footings for foundation walls. All you need is a basic wooden frame. Now this is not a footing exactly. It's kind of a combination footing and wall, but I talked to the guys at Fastfoot and they tell me it's going to work just fine. The fabric will contain the concrete. You can see one spot here that would have been tricky to form with wood or metal, and that's because the rock tapers quite a bit here. So if everything works like it's supposed to, this fabric will contain the concrete, and that's one of the reasons why I used it. I'll show you more examples of that as we walk around a little bit. But another reason is because I want the wood to stay clean. There's a fair amount of wood in this form, and I don't want it all covered in concrete, because as I said, I want to use it for wall sheathing and different projects. So that's the promise of the Fastfoot, and this is ready to pour now. Now the rest of it isn't, because I've only created the outside wall of the form. I'm just starting to create the inside wall now. So let's go and take a look over here. I'll show you a few details, things that have worked pretty well so far. These fasteners are called cap staples, and they go on with a special air-powered gun, and it combines a staple with this plastic washer, so it gives a lot of holding power to the material in this case, and I want to give it every opportunity to work. I don't think there's going to be a whole lot of downward pressure, because as I installed this Fastfoot stuff, I was careful to make sure there's lots of slack. I wouldn't want it not to have enough slack and then the weight of the concrete pushed down on it, maybe tearing it away from the formwork. But I was very careful with that all the way around. Another thing is this rebar here. I do not like to use steel rebar in any kind of a pour. It might be okay, but if moisture gets in and starts rusting, you know, we've all seen what happens. When steel rusts, it expands and it can pop off the concrete. And I mean, why would I want to worry about anything like that? That's why I used fiberglass rebar. It's been great to work with. It cuts with a little power hacksaw, a little battery powered 12 volt Milwaukee hacksaw that I have. And it's not just sitting on the rock. Each one of these fits into holes, 5 or 6 inches deep. I drilled them oversized and filled them up with anchoring epoxy and then jammed the vertical pieces in. Just a few days ago, I finished tying the rebar. This is all done according to an engineer's design. He's calling for these uprights every 20 inches, wherever I can, but because I'm dealing with irregular bedrock here, for instance, I couldn't put one here because it was just a rock crack there. But in most places, everything is as it should be. And when it comes to fiberglass rebar, of course, you can't bend it like you can regular rebar, and that can be an issue around corners. So let's go down and take a look at the other end of the form, and I'll show you the kind of rebar they provide for corners when you're dealing with fiberglass. This is the tallest part of the wall. It's about 40 inches tall. So the engineer called for horizontal lengths of rebar every 12 inches, which is what we've got going on here. And then here are those corner pieces I was telling you about. Rebar is important for concrete because it provides tensile strength. So that's strength that resists the pulling apart force. Concrete is very strong in compression, but it's not all that strong in tension. And that's where the rebar comes in. There's no need to make a strong joint between one piece of rebar and another. You just have to overlap sufficiently. And once the concrete is here and it's vibrated in and it hardens, the undulations here on the rebar are going to lock it into the concrete. So these wires, you see, they're just there to hold everything until the concrete gets put in place. This whole foundation thing will make more sense to you if you take a look at the plans package that I mentioned before. So this is what Calhoun provided me with after we settled on the design. The first page here is engineering loadings. This is what the engineer that I hired to design this foundation used. I don't understand any of the numbers, but they made sense to him, and that's how we came up with the pattern and spacing of rebar that you see in the actual foundation. This is the page that I've been using most lately as I lay out the foundation. It shows the overall dimensions, very important dimensions too, because the metal frame, the legs of the metal frame need to land properly on the foundation wall. So we've got the spacing here between the metal legs, and I'll show you those in another video. We've also got the footprint here of different things that will mount onto the foundation wall using some very heavy self-tapping, well, they're not self-tapping exactly, you need to pre-drill, but they're anchors. They're like wood screws except for concrete, and they're big. They're thick in diameter, all engineered, and I'll be making some templates of these things so I know where to drill so everything lines up as it should. This is an end view of the structure here. So when I was talking about legs, I mean these things. They're going to sit on top of the concrete wall. I've specified a 14 by 14 foot garage door opening, and that's for both ends. That's hugely valuable, actually. It's much better to have two big doors instead of one. It effectively increases the storage capacity of your building, because now you don't need to keep a clear travel path to get things from this end to that end, because now you've got two ways to get in and out of the building. It also improves ventilation, so that just seemed like a no-brainer. In another video, I'm going to give you a close-up tour of all these parts. I was very impressed with Calhoun's manufacturing on this. One of the challenges of working with a rock situation is that you can't pound stakes into the ground like you normally would in a soil situation. That's where the 5/8 rebar comes in, as I mentioned before. But something else is required too, and that's a very reliable corner position. So I bored some 4-inch diameter holes in the rock using a coring bit, and then set this angle iron into that hole, filled it with mortar, let it harden, plumbed of course, all braced so it was straight up and down. And then I used a laser level to determine the exact level spot for all of these corners. There's one on the inside of every corner, and you can see over here there's one on the outside. But the tops of these all around the building are perfectly level. That's kind of my surveying monument, if you will, and everything stems from this. So I expect that I'll be pouring concrete here probably in a couple of weeks. I do need to create the same kind of wall that you see on the outside, on the inside, and then I'm going to plumb those forms and brace them, and then I think we'll be ready for the pour. We're dealing with almost 250 feet of form. Most of it's 9 inches wide, so it'll be maybe 15 cubic meters of concrete, so 2 truckloads should do it. And I'll be sure to be making a video on that day, and you'll see how it goes, and you'll see if, as I hope it does, this fast foot stuff manages to hold. My main concern is here at the 40-inch end, 40-inch tall end, but my plan is to pour about 1 foot or 1.5 feet of concrete, not a whole lot of pressure, let it get half hard, and then finish up the form after that. So I'll keep you posted.